Our meeting will begin in 10 minutes. Please take your seats. Our meeting is about to begin. Please take your seats. Our meeting will begin in 5 minutes. Please take your seats. Our meeting is about to begin. Please take your seats. Please take your seats. As a courtesy, we ask that you place all wireless devices on silent. Our meeting is about to begin. Please take your seats. Our meeting is about to begin. Please take your seats.
Performance. It's what separates the winners from the rest. Those who perform at the highest level are the ones who make history and shatter the status quo. But what is the key to better performance? What makes a product smarter, faster, stronger, more reliable? The answer lies in your test data. By tapping into the vast power of test data and advanced analytics, NI helps you discover insights that supercharge the quality of your products and drive countless efficiencies across your organization. Less downtime, fewer defects, greater scalability. Some might say it's a bold concept, rethinking test as a way to boost the performance of today's complex products and the businesses that create them. We simply see it as another way NI is committed to engineering your success.
Ladies and gentlemen, please welcome to the stage NI Vice President of Software Strategy, Shelley Gretlein.
Wow, what an incredible event. Good afternoon, everyone. It's been really amazing to connect with some old friends that I haven't seen in a long time this week. It's been really, really special. So I'm excited for this afternoon. As you may have heard, my name is Shelley, and I'm a longtime NIer. And it's been a really fun week to see all the new products and see all the partners. What we have for you this afternoon to close out NI Connect is an incredible panel of experts. You guys are going to learn a lot. I already have learned quite a bit from these folks. Expect to hear about some non-sci-fi scary hacks and breaches that are happening in B2B today. Expect to hear about some tips and tricks on how to use simulation and test and data to really drive the product performance of what you're building. From a format perspective, each of our experts are going to come share a little bit about their current focus, just to give you a teaser, and then we'll jump straight into the Q&A. So without further ado, I would love to introduce our first panelist, Dr. Lisa Porter. Dr. Lisa Porter is currently the co-president of Logic. She was the former Deputy Undersecretary of Defense for Research and Engineering, where she was responsible for the research, development, and prototyping activities across the entire DoD. She oversaw the activities of DARPA, the Missile Defense Agency, the Defense Innovation Unit, and the DoD Laboratory and Engineering Center. Dr. Porter previously served as the Executive Vice President of In-Q-Tel, and prior to IQT, Dr. Porter was the president of Teledyne Scientific and Imaging. She was the first director of IARPA in the Office of the Director of National Intelligence, and previously served in the Aeronautics Research Mission at NASA. Dr. Porter holds a bachelor's degree in nuclear engineering from MIT, and a doctorate in applied physics from Stanford, whose mascot is a tree today. She received a NASA Outstanding Leadership Medal in 2008, the National Intelligence Presidential Meritorious Rank Award in 2013, and the Office of the Secretary of Defense Medal for Distinguished Public Service in 2020. Please join me in welcoming Dr. Lisa Porter. Good?
Okay, it's really weird when you get up here and you see this huge face of yourself. Okay, so thanks everybody for coming here. As Shelley was explaining, we're just gonna do a little bit of a teaser here, so I'm just gonna try to get you guys interested so then you'll stick around when we have the really good conversation. So to set the stage, what you see up here is a very compelling set of data, because we all love data, from just last year, a year ago. The top 10 companies in the world by market cap. It's a pretty phenomenal list there. And the point I'm trying to make with this information is there's a lot of conversation around, of course, what supply chain, right? And it's funny, everybody has an opinion about supply chain and how to fix it. Like your Uber driver probably gave you an opinion about that this morning. And yet the concern that I have, and a lot of folks I have, that I know have, is that we have to make sure that as we think about the challenges that supply chain have obviously highlighted for various industries, that we don't break what is great about it. And that's why this chart is here, because in the microelectronics industry, as many of you are well aware, it's a very globally distributed, highly intertwined ecosystem of thousands and thousands and thousands of participants, right? And it has evolved that way because of market dynamics. And it's evolved in a way that is optimized, right, for efficiency and for innovation. And that is why we see this kind of incredible output, right, in terms of all these industries that are very reliant on the success of microelectronics and what that supply chain is doing. So the efficiency that has come about from this great distributed, intertwined, complex network of vendors has given birth to incredible economic growth, as well as consumer access, right, at affordable prices. We all take for granted the cell phones we walk around with in our pockets today. So this question I have up here that I'm hoping we can stimulate discussion around is how do we improve this resilience problem that we're all talking about now, right? It's very efficient, not so resilient, whether you're talking about COVID or whether you're talking about what Shelley was referring to, malicious actors trying to actually hack into your system. Either way, the current supply system, not so resilient. But we want to address that without destroying what makes it great, what makes it so efficient and therefore keeps the cost down to allow the economic growth that we've been enjoying as a society for decades now. And so just as a teaser, I'm not going to brief the next chart. It's really pretty, though. You have to give me credit for that. But I do want to say that I would argue that part of the answer lies in applying zero trust, which many of you have probably heard a little bit about, and you may not quite know what that is. We'll talk about it a little bit more in a moment. But this notion of, hey, we can't make things perfect. We can't make them perfectly secure. We can't make them perfectly trusted. We have to stop trying to do that because it leads us down faulty ways of thinking and dangerous, actually, ways of thinking in terms of security. Let go of that, focus on resilience, and reset our minds around risk assessment, risk management, which then there's not a one time you do this and you're good to go. This is something that I think we all know has to be continually done. We're always learning. We're always learning about new risks, learning about new hacks, and Shelley will probably ask me about some of that, so to get you all scared and stuff. So, you know, that's the thing. We've got to constantly thinking, what's coming next? How do we share that information? How do we do it so that we all can remain competitive and at the same time benefit where we all can benefit collaboratively? So a lot to discuss depending on where we go today on the conversation, but hopefully we'll get into some interesting things. And thank you for the time today. Thanks.
Thank you, Lisa, so much. We want to dive into that. And as you're already kind of picking up, I think what we're really hoping to take away is some of this pragmatic advice, right? How can we get to the places we need to be safe? So our next panelist, y'all are going to be excited to hear from, is Dr. Bernard Dion. He was originally the co-founder and CTO of Estrel, and that's actually how we first started interacting. Back in the early 2000s, I was working with the LabVIEW Real-Time, and we were working on a lot of safety critical systems, and so we interacted back in the day. And then Estrel actually was made part of ANSYS in 2012, and that's when Bernard joined ANSYS. So he's now an ANSYS Fellow and Chief Technologist of the Systems Business Unit. Bernard is responsible for defining, promoting, and supporting model-based systems and software for defining critical systems. Bernard has an extensive experience in the software aspects of certification, and he has been the secretary of the tools group in the DO 178C committee, and he's currently a member of the SAE G34 working group that is creating the safety standard for introducing artificial intelligence in aviation, right? Autonomous smart planes. We want to talk about that some more. Bernard holds an electrical engineering degree from École Centrale de Lyon in France. They're very well known for their applied science and engineering programs. And in fact, they're continuously ranked in the top 5 schools for these graduate programs. Bernard also holds a Master of Science and a PhD in computer science from the University of Wisconsin-Madison. I know Badgers because of Jonah, so I already knew that one. Please join me in welcoming Bernard Dion.
Thank you, Shelley. I want to give a few words of introduction as well. So, in fact, what I wanted to present today to start with is the notion that we have to address more and more systems of systems. So, these systems of systems are made of individual systems that have subsystems and so on. And that's a very common situation. And to illustrate the way to work on this, I bring up this slide, and on the top left, what you see is that satellite is used to establish communication between the system elements. This satellite communicates with ground station. So this is where you see the communication aspects. And at the bottom, you see a demonstration where you have, in fact, two copters that are flying in formation. One is with a pilot, the other one is autonomous, and they are flying together. And now, what do we do to address the design of such system? And in fact, what I want to say is that there is a lot of interest to bring together model-based system engineering with simulation and with testing. And so starting on the top, what you see is that in the beginning, there is digital mission engineering, which is the design of the mission with the concept of operation and the establishment of the communication between the elements of the system of systems. And then when you get down to the individual systems, you apply model-based system engineering techniques to gather the design information about the system elements that you are designing. And then you get down to the software part, and again, you can use model-based software engineering techniques to design these software elements. And these things are these days getting more and more complex, and in particular, I'm personally involved in introducing AI into such systems, and then the question is, how can you trust them? And so, whenever you design the system, you have to rely on simulation, and simulation at various levels, functional, physical level simulations, software simulation, and all of this simulation is used to, in fact, to work on the properties of the system. You want to guarantee safety, reliability, cyber security, and all of this is going to rely on some level of simulation to test hypotheses, to verify that you have done the job correctly. And this is where is the testing coming that you see at the bottom with NI, and there is the necessity to run a lot of testing all throughout the system design activity. That's an absolute necessity, and so this is why we are working together to do things like hardware-in-the-loop testing for sensors in ADAS system, where you need to assess the robustness of the system, and this is only by doing testing that you can completely verify the robustness. You have to do testing for RF communication, and also here HIL testing is necessary. So these activities between design and testing are completely complementary and necessary. And the last thing I want to say is that it is not just for the initial system design, where you have these interactions, this loop between design and testing. It is also during operation, because these systems are going to be typically monitored, and then you can use, of course, measurement, but also digital twins of the system elements to learn more about the way they are working in operation, and to do what-if studies, for example. So it's a constant iteration between the design, the simulation, and the testing.
Awesome. Thank you. Thank you, Bernard. Thank you so much. Yeah, I think we'll hear a lot more about the iteration and how things have changed, right, from these traditional kind of linear processes. So we're excited to get into that more. Before we do so, we have one more panelist who I'm excited to introduce all of you to. Some of you may already know him. Keith Odom will join us. As Senior Vice President and Senior Fellow at NI, Keith collaborates across NI to help drive our long-term innovation. And in fact, Keith has led some of NI's most successful innovations to date. He's helped build our ASICs, our FPGAs. He's been part of more than 50 different patents across our product line in the areas of bus interfacing, reconfigurable I/O, hardware and software interactions, timing and synchronization. Keith was instrumental in developing key architectures, including the NISTC, device system timing controllers, compact DAC, the NI synchronization and memory core architecture, PXI, LAVIA FPGA, bus interfaces for NI PCI, USB, and PCI Express. In 2006, Keith was elected an Outstanding Young Engineering Graduate for the University of Texas at Austin. Keith has also served on the Advisory Council for the Electrical and Computer Engineering Department. Keith holds a master's degree in electrical and computer engineering, a bachelor's degree in electrical engineering with a computer engineering specialization from the University of Texas at Austin, and a master's degree in education technology from the Thumb University, Texas A&M. Keith, come join us on stage.
Thanks, Shelly, for that introduction. I'm glad to be here today and have a chance to talk to all of you. So one of the things that's really fun about my job is I get to spend a lot of time immersed in technology and thinking about the future. So I work with across our business units and some of our key fellows, and some of the things that we've been looking for are what are the important trends in the industry that are going to impact the future of test. And so I've only got 2 minutes here today. I could probably talk for hours, but let me just give you a few sound bites on a few of these. I think you've probably seen through some of the keynotes with Charles and Thomas yesterday and even Eric, the importance of data. And so probably some of you are thinking, yeah, of course data. Data's almost passé. You know, we should all be using data. It's so easy. You know, I can tell you one of our own personal examples is we were able to do some AI and machine learning and see a 90% reduction in test time on one of our RF products. So that's the good news. The bad news is it took us about 2 to 3 months to actually wrangle the data to do the analysis and another month to validate whether that was actually real results or fake results. And so I think probably many of you, we see that as an important trend, helping you get that data organized in a fashion that is available for analytics and machine learning. One of the things that we also see as a big important trend is really one of the things that we've always done as a company is try to leverage commercial technology and where there are big investments going on. And so really you look at cloud scale, that's an obvious area of investment. So in the cloud infrastructure, so you've obviously got things like multi-core processors, high-speed networking, high-speed storage. Those are obviously things that we want to leverage. But I think as you get into the higher levels of the stack, you look at things like infrastructure as code, containerization, the efficiencies that you get by doing continuous delivery. So bringing those cloud scale technologies to the test and measurement industry we see as an important thing. We've done some experiments where we're able to scale and get 10x performance by using cloud hyperscaling in some of our RF tests as well. Bernard talked about models as well. We think that's a very important trend. This is one of these we talked about. Thomas mentioned the shift left trend. So how do we move more into the simulation world to get that efficiency that you get by doing those quick iterations in a simulation or virtual world? You know, in many industries, you maybe go, we're already there, right? Some of the things I've been doing before. I mean, my experience in doing chip design, obviously you have to do that in simulation when it takes 3 months to get a prototype. You've also got that in some really safety critical areas. But how do we move that technology, that design in the virtual world, the efficiency from that, from areas where it's a must do, because that's the only way to solve the problem, to where it's the most efficient way to do it. And so that's an area where we think there's a lot of opportunities to partner, collaborate with Ansys and other companies in that area. And lastly, when we talk about data or models, the important thing is you have to get the real world data to feed the analytics and to feed the models to check that for correctness. And so we really see that influencing trends in how do we do our hardware. So really network distributed measurements. You know, we talk about sometimes this is the files on hard drive. You got a tester, you got some data, it just sits on a hard drive. We have to make that data accessible in a network and configurable way so that it's available to this modeling and data analytics. And so we see that impacting the future of how we design a lot of our products. So we're looking forward to a lot of exciting opportunity and some good Q&A today. So let me turn it back over to Shelly.
All right, proceed. Thank you, thank you. Okay, so you talked about some trends are obviously meant to address challenges. So let's just kind of open up with some challenges, because I feel like we'll build on that. And Keith, maybe you can go first on if you had to summarize some of those elements, what are you seeing as the biggest challenge of test today?
I think one of the things that we talked on, Bernard mentioned it in his discussion, is really as you look at a lot of these systems that are being designed with AI and machine learning and trained, you've essentially got this black box that you've trained on this stuff. How do you actually know that that network that you trained is doing what you intended to do, right? I mean, you can see a lot of examples in your own home, right? Maybe you talk to your smart device, it doesn't understand you, right? And so what happens when it's driving your car or it's flying your plane and it doesn't understand the scenario, it gets confused. And so that's one of the areas that we've been looking in terms of like that intersection of test. How do you know that you've done enough testing? How do you know that you've met the requirements? What are the scenarios to make sure that you have a safe system? And so I think that's a really interesting challenge going forward for testers and designers.
Yeah, the right scenarios, enough scenarios. Yeah, I think we've had that discussed a lot. Lisa, you kind of perked up when Keith was talking about how much data, right, and wrangling that data in that kind of even simple example of testing a product.
Right.
What are your thoughts there on there's just more data?
Yes, yes.
How do we keep
and
it safe?
you know, that's a true statement regardless. So I have a little bit of history with machine learning generally, and that is always a problem, what Keith was saying. And in the particular architecture I had shown you guys of the zero trust model, what is that fundamentally about? It's about collecting data all along the life cycle and assessing your risk, right? And measuring the things that you decide you need to measure to understand that risk at a given point in time and adapt and adjust. That all sounds lovely, but to your point, you're not going to do that manually. So you've got to automate these systems, and you're going to need to rely on some kind of machine learning and maybe physics-based modeling. And how do you validate? How do you know it's telling you what is true? And I think that's going to be an enduring issue and an enduring technology challenge of, you know, they call it data curation in some places. They call it data wrangling. You use that term. You'll hear these terms a lot. People kind of poo-poo that because that's not the sexy part of the problem. It is the biggest part of the problem, is understanding how to actually curate that data so you can use it. Whether you're answering a question about risk, whether you're answering a question about quality, performance, whatever it is, how do I actually make sure the data that I'm using is in the right, you know, format, and then I trust, quote unquote, the output, that I'm confident that is the right answer that I'm getting. So I think that's just a general truism that you're only going to see more and more as we get to more and more data, right?
Yep, yeah. Yep. So you spoke about learn and try again, learn and try again. Bernard, I feel like this resonates with you a lot. We talked about this, we're not linear anymore in terms of learning and simulation. You want to talk about iterations and things you're seeing?
One point I want to insist on is that in order to trust such system, there is a need to produce scenarios that are going to be used for testing, that are going to produce the data that we are talking about. And there is a lot of thinking to put into the way to create these scenarios. And I'm currently involved with FAA and EASA and aircraft manufacturer, for example, to what are the rules, you know, to be able to certify that the system is running correctly, that you can take this plane. And so these are very difficult questions, and they rely on statistical testing, you know, this kind of techniques, and these are very key topics for the future, I believe.
And something you mentioned earlier, Bernard, which I think a lot of the attendees at NI Connect appreciate, which is the cross-industry sharing, right? There's some learnings in automotive that aerospace can see, and certainly there's a ton we can get from semiconductors. So I think there's been a lot of those types of conversations. Well, how are you doing it, and how can we learn from a completely different industry and apply that to what we're doing here as well?
This is something I have seen in these 2 days, like people saying, I'm in aviation, maybe in automotive, you have done things earlier on these topics, and we can learn from each other. The constraints are not the same. Safety is not seen in the same way. There are different aspects, but still there is a lot to learn about sharing, and I believe that companies like NI or ANSYS are in a very privileged position because we are addressing, you know, the different domains, and so I think this is quite interesting.
Yeah, the acronyms are quite different between industries. It feels like half the time it's decoding the acronyms.
Yeah. Sometimes they're the same, they just mean different.
That's true, that's even worse, good point.
Yeah.
Lisa, I want to go back to zero trust. This is a topic you're out there, you know, educating on. What are some of the misconceptions you're running across, and how can we help? How can we educate?
Right.
What do you hear a lot?
Right. So, you know, it's interesting. Zero trust has become very popular in the cyber world. So for those of you who are CIOs or CISOs, or you work in IT, you're very familiar with this term. But, you know, it's almost become, and I said this morning to someone, it's almost like the AI of 2022, where everybody's now saying, I can sprinkle it on your system, and, you know, it's like a magic fairy dust, and then everything becomes secure. And as soon as someone says says that, I just cringe, because zero trust is actually a philosophy, it's not a technology, and it's about the reality of things cannot be perfectly secure, and people cannot, I should say, systems cannot be perfectly trusted. And this is relevant for this world, in the world you guys are in the supply chain in particular, because we're hearing all the time we want trusted vendors, trusted suppliers, right? The cyber community has learned the hard way many times that it has to stop thinking that if I have my place, you know, in the United States, or if I build a huge barrier, perimeter around it, it's now safe and trusted and I can know that it's perfectly secure. And we keep learning that that can't be, you know, that's not the truth, right? So Edward Snowden taught the intelligence community this, oh boy, back in 2013 now, when everybody thought they could build a perfectly secure network. Oops, once you're inside, you can do infinite damage, as he did. SolarWinds, many of you have probably heard of this. This was a nice, you know, American company in the middle of the country, and the extension of which that damage was is still being figured out, okay? So this notion of I can build something that's perfectly secure actually makes you less secure, because it lulls you into the sense of now I can put a lot of confidence that this thing is perfect, and I'll put too much stuff in there, let people do too much with it. And so zero trust is no, no, no. Never trust anything, always verify, right? Never trust, always verify. And what does that mean? That means collecting data, assessing. Maybe I trust you in a particular context right now today to take this particular piece of data, Shelley, but just because of that, I'm not going to let you necessarily tomorrow come back and take a different piece of data from me. There's nothing about you that makes you infinitely trustable. That's important for supply chain.
Most
I'm
people.
sorry. Same is true about all of us here, let's be honest, right? So that's the whole point, right? That's the whole point. And so the question is, how do you then take that philosophy that people kind of intuitively get once you say it? It's like, you know, you're right. Life is messy, it's complex, stuff happens, we can't assume perfection. How do we deal with that reality? And we have to deal with it by saying it's risk. We all do risk assessment every day in our lives. When you go outside, you might get hit by a bus. You know, you might get in a car accident. Something bad can happen at any time. You don't sit frozen in your house and say, I'm just not going to do anything. You kind of exist with that awareness, and you're always doing a risk assessment, whether you even realize it or not. We have to bring that framework to how we build our systems, how we rely on our supply chain, and that's where resilience comes in, right? It's assume bad stuff will happen, make sure you're prepared, whether through redundancy or, you know, there's a lot of different approaches to it. I won't go into all of it. I'll just say there's a huge opportunity here in the test community, because a lot of it is going to come down to what am I measuring, and then how do I take that information and translate it into a quantitative assessment of my risk, so that I can assure you that this particular part I'm giving you is at a certain tier, what I call a tier, or quantitative assurance level. It's a level 1, it's a level 2, and I can correlate that with a risk profile. And the obvious question y'all would ask is, well, how do we do that? And or I'll talk in the same language, like your tier 1 might be different than your tier 1, so that's useless to me. Yeah, unless we have something called standards, right? So this gets back to the whole, how do we get people collaboratively to work on standards that advance this concept of a quantitative risk approach to supply chain, whether it's for microelectronics or frankly for other elements. So it's a very rich area, and it takes a lot of, I think, appreciation of nuance. I come from the DoD and regrettably in the Pentagon, which is super crazyville, and nuance was something that people really didn't, you know, they were very black and white. It was like, I want the easy button, I'll spend billions or whatever you want me to, just tell me what the easy button is, so once I press it, everything is perfect, right? That's what people like, and it makes them feel good, and it's like, no, there's no such thing. There's no finish line. We've got to continually get better. We have to be resilient against things, that bad stuff happens. Let's take that mindset, right? So it is kind of challenging to get that across to people who are policymakers, who just kind of want to, again, say, well, we're going to make it so. Everything good, you know, everything becomes good. And so that's the challenge that we have, I think, as technologists, to try to explain risk, probability, statistics, right? Things that we were talking about. It's really hard to convey that to people who are, you know, not technical, especially when they're in the government, by the way. It's like,
no offense, there's a few of you here. It's going to be fine. Yeah, I do think the idea of no finish line is really sticky, though, too. Yes. And we can't architect these systems in a way that we can update them and keep learning and using the data. But it's not a done and let's move on to the next problem, right?
Exactly.
So I think that's pretty sticky. As you're talking about risk, I'm reflecting on something Bernard said earlier, which was on digital twins. So I'm going to switch this a little bit, and he's describing this, it's not just a design thing. We've talked about digital twins in automotive and aero for a while, and it's a design engineering kind of concept and task. And it's like, no. Think about digital twin in use. And then I'm thinking risk. Okay, so now the plane is flying, and what are you talking about? So tell us a little bit about this, Bernard, how this can evolve.
So this is definitely something that is already existing. For example, engines for planes are monitored in that way with digital twins. That has been done for a long time. This is getting more and more common as a technology. And just to give you an example, you cannot put sensors everywhere. There are places where you cannot have a sensor. If you have a digital twin, you get some sensors that allows you to start the simulation, and then you can have virtual sensors. And so you have other virtual measurement point, if I can say so, that you can use in your data collection. And so you can answer more questions about what's going on. You can do preventive maintenance. So this is the role of digital twin, and these things are now getting more and more common as a technique.
Yeah, I think it's exciting, for sure. I also was listening yesterday, if you guys were able to hear Dr. Choi from Samsung. He was talking about these mega trends, driving 6G, fascinating data points. And two of the things that I noted yesterday, again, of course, AI and ML, we know that that's technologies that are just accelerating incredible innovation. We're learning a lot all the time. But he also dropped this stat on us that by 2030, there'll be 500 billion connected machines. 60 times more than the humans on the earth at the time. And so just really stuck with me when you talk about security and safe devices and smart devices, and are they doing what we thought? So I don't know, what are the implications of that scale when we're talking about connected devices? Maybe I'll start with you, Keith, and then Lisa, I'd like your thoughts as well.
Sure. Yeah, I mean, I think a lot of when you talk about that number of devices, I think you've seen some of the thought material on 6G. It's really not using cellular to talk between people, it's really machine to machine. And so you think about things that we want in terms of autonomy, talking V2X, those kind of things. And so I think you've got that implication of those number of devices. You've got the interoperability challenges that go along with that, and then you've got security challenges that go along with it. And so I think you have to then, like what Lisa was talking about, I think you have to have a different cost optimization structure. It's not always COGS, it's COGS plus security or supply assurance. And so I think some of the challenges are actually figuring out that right risk management and cost optimization problem.
That's right. Yeah. Yeah, and to amplify on that, it's as someone who, as Shelley mentioned, I was in the intelligence community for a while. So you can imagine, all those spy movies you've seen. So those things are kind of true. Like people think, oh, that's science fiction. No, it's actually not. So unfortunately, what that does to someone like me is it makes me very paranoid. So because that doesn't mean it isn't true, right? So when you think about everything connected to everything else, we're already seeing in the cyber domain just the effects of how easy it is for someone to remotely get to you. And you've heard of ransomware. Maybe you didn't know that ransomware is so popular that it's now RAAS, Ransomware as a Service. Can you believe this? Isn't that hard? This is like a business model, right? Yes. Isn't that horribly scary? Yeah. Well, imagine now your ransomware is not just about your networks, but it's about your chips in your car. Imagine every one of the cars that you produce, I'm going to pick on GM only because I know GM was here, but it can be any automotive company. All of a sudden, somebody can let you know what? You're going to pay me $5 million in the next 24 hours, or every car that has this chip in it is going to, melt down, or whatever, right? That's very scary. So when you think about ubiquitous connectivity, which is how I describe this 5G, 6G transition, what you're talking about, everything talking to everything else, there's a lot of upside to it. There really is. There's a lot of good that's going to come out of this, but we do have to be thoughtful about the cost-risk trades, what things are going to be more important to us to protect and therefore perhaps not have quite so much connectivity. And as we have that connectivity, what measurements are we making to ensure that our risk is below a certain level? This is going to be requiring, I think, a collective and collaborative approach to how we do this. It's very complex. Yeah, and it's moving fast, as you all know, right? So have you been in meetings? I have my business partner, he has this habit of leaving his Siri on, and we'll be in a meeting, and then suddenly it's trying to figure out what he's saying. And we're like, oh shoot, we hope that he's not dialing that person. We were just talking about them, so that's not good, right? That's just a little example of what we all kind of feel we're sharing now, right?
Well, and think about, I mean, I was reading a story the other day, I mean, you look at some of these conflicts, your devices that are automatically updating their firmware over the internet, and what happens is, where does that update come from? Can you trust that person? The political dynamics change, and so it becomes an attack vector versus
exactly right.
So there's a lot of challenges there.
Yes, yes.
So it's a buzzkill, a little scary.
Yeah. Well, you know, we want people to be thinking, right?
No, it's
Talk about puppies now.
Yeah, we'll talk about puppies.
No, I told the team was really generous. They said we could not script things. So I have a surprise. If you guys look under your chair, I have something fun.
Oh.
Grab your whiteboards.
A new car? That's so nice. Thank you.
You get a car, and you get a car.
You get a car.
You all have whiteboards. Bernard, you do as well.
All right.
GM might give away cars.
Thank you for the green marker.
Okay, we don't have a lot of time.
Look at
I know
this.
Jason
This
watching.
is really...
So you have a new whiteboard. Bernard, I can help.
Yeah.
Can need help.
Did you get
I
it?
found
There
it.
we go. Okay.
I found it.
They don't know about this. Okay, so here's what I want you to do. These are all, you heard their accolades. Brilliant humans up here. I'm going to give you a couple of seconds, like 20 seconds.
You're going to play the Jeopardy theme?
And I want you all to draw the future of test.
Of test?
Yep.
Really?
Yep.
Are you serious?
Your time is ticking. Draw.
Okay. All right. You know what I'm drawing, right? Because I'm being a wise ass right now.
I had ideas.
You guys can guess what I'm drawing.
I'm ready. 5 more seconds. And then you'll get to describe your drawing to everyone.
So obvious, right? I mean, come on.
All right, pencils down. Kids are all taking finals.
Oh, look at you. You actually took it seriously. Okay, good. Bernard, you go first.
Bernard's a rule follower.
He is a rule
Lisa,
follower.
do you have anything to say about
You
your
can
drawing?
tell I'm not, right?
Do you have anything to say about the future of dance? Your drawing? Or are you good?
I'll let Bernard go.
Bernard, tell us what you drew.
He's really
Describe
prepared.
What I drew was virtual, real, and test.
Yay. There we go, bringing the worlds together. Yeah. Look at this. Also talented artist. All right, Keith.
All right.
Got for us.
So I have a
gosh,
cloud,
gorgeous.
of course.
Yeah.
And it's raining.
No. These
Hail.
are sensors feeding the cloud. It's going up. It's not going down. Sensors feeding the cloud. And then you've got your intelligent, hyper-automated brain in here interpreting all of your
That's
test
good.
data.
That's good. But you forgot the little
Oh, the malware? Yeah, the bad guys.
That weird sensor on the end.
Yeah, I'll draw that on your side. So there we go.
Keith, that's beautiful. That's good. This was vulnerable. This was really great.
Bad guy. See, he's attacking you.
Lisa's injected the malware
I've
into my
injected the malware.
user
Here you go.
Ransomware as a
This is-
service. Okay. Our time went really fast. I don't know how that happened.
You're totally losing control of this, aren't you?
I know.
Okay.
It's okay. I would like to end on some optimism, though. I know,
Okay.
again, we've been chatting a whole bunch. We've all been in meetings. We've been seeing new technology. There's a lot of crazy things happening. But I'd like to end each of you to answer just kind of what makes you optimistic when you look out at the future of technology, products, whatever it is, processes even. What gives you some optimism that we're going to be able to figure this thing out, whether it's keeping things safe, whether it's higher product performance. So Keith, why don't you go first, and I'd love each of you to answer that.
I'm always amazed at how the technology can solve these societal larger problems, right? I mean, if you look at what we were talking about, I mean, I know when I was in college, it's like, oh, well, we'll never have renewable energies. Nobody's going to pay for solar. It's too expensive. And you look at how quickly there's been an inflection point, right? And you've got all of these alternative energy sources. You look at all the energy going into EV and zero pollution vehicles. And so, I mean, I'm always impressed that as long as you get the incentives right and you get, those first movers and that. So I'm always optimistic about how technology can help make the world a better place.
Good. Bernard?
So what makes me optimistic is that it is what we just described is just really happening. It is happening, and it is not just a vision. We say we should do this and this. we are doing it. And the second thing I want to say is that people from different disciplines are cooperating together to make it happen. And this is an absolute necessity. You know, the work of a system engineer is to bring these elements together with various disciplines. And we have realized that without doing that, we could not do it. So we do it. And so that's what makes me optimistic.
So I completely agree with you, Bernard. I think that, you know, I've always believed that a lot of innovation occurs at the seams of different disciplines, right? If you can get, the reason I brought up the cyber is I found that outside of cyber, people are still not necessarily paying attention to this looming threat. And you know, everybody gets siloed, to overuse a term, where they say, you know, I'm focused on my particular problem, I've got my day job, you know, people say that all the time, but sometimes it's really valuable at events like this to talk to people who are in other industries to say, oh, wow, you guys have a similar problem. You use a different acronym maybe, to your point, but we can really learn from each other. And one of the things I really hope when I talk about things like Zero Trust is that people realize that this is really something that whether you're Qualcomm, whether you're GM, whether you're a 5G-centric, you know, company that's really looking at how to deploy these kinds of amazing capabilities, that you realize that you need to collaborate on how you think about this. This isn't just the supply side trying to offer something up and hope that people will pay for it. This is something where the demand signal should be there to say, you know, whether it's safety or security, and by the way, those are very linked entities, we need to think about these things in a deep way. And I'm with you, Keith. I mean, I look back at, you know, I'm old now, and we look back at like, I'm a kid of the 80s, right? And think about what it was like back then for those of you who are old. We have come so far. It's like, you know, it's amazing how much we've accomplished in these decades. And like I said in my opening comments, think about how hard it is to build a microchip. It's amazing the incredible complexity in a fab, right? The design tools, and then the fab, and then the weight, all of that. It's incredible, mind-blowing. And yet we all take it for granted. We walk around with cell phones in our pockets that have compute power greater than the mainframes we worked on when we were interning, in my case, right? So I'm always optimistic, to your point, Keith. I think we're always getting better. We just have to be mindful. We can't let ourselves get in this state of everything's perfect. We always have to be better. So I am optimistic, honestly, even though I might sound a little paranoid about things.
Slightly, for the mature folks in the audience.
Yes, yeah. Mature, sorry. I'm mature, I'm not old, that's right, sorry. I probably committed some offense there, I apologize.
Well, the panelists are going to stick around. I know that went really fast, and I know they have lots to share with y'all. So first, just please a round of applause for all of you. Thank you for taking time. I did want to close this out briefly because this is the last session, which is crazy. It went really quickly. So I wanted to share at NI, we have 3 values. You know, we have bold, we have connectors, and we saw a lot of really cool connection this week. That was special. I think we've missed it. I was reminded, you know, being able to see what you as our customers have done is so incredible, and the people are so incredible. And our 3rd value is to be kind. And with the events in Buffalo and Uvalde, we have to be kind to each other. It requires it. So this is our community, our customers and our partners. And we need to be there for each other. So I wanted to address that. And I know you guys are all thinking of these families and these children. So let's work better together to make this world a better place. And thank you for coming to NI Connect, and stay safe, everybody.